Each summer, an aircraft ascends over the majestic peaks of Utah, its cargo bay doors opening to release thousands of juvenile trout into the tranquil waters below. One flight, one lake. This year alone, 11.6 million of these young fish were introduced. This remarkable process has been repeating for 70 years now. Yet, the very lakes once presumed desolate and devoid of life by generations of people were in fact teeming. What had thrived there for 10 millennia before the arrival of the first trout has now nearly vanished. What precisely inhabited these waters? And how did its disappearance go largely unobserved? In Utah's Uinta Mountains, over 650 lakes lie nestled above the timberline, inaccessible by road. 10,000 years ago, melting glaciers sculpted the bedrock, leaving behind pristine basins filled with crystalline meltwater, and little else. Not a single fish, no scaly predator with fins. Instead, a delicate ecosystem emerged. Frogs, salamanders, insect larvae, and minuscule zooplankton populated these isolated lakes. For 10 millennia, they flourished, untouched by any swift-swimming adversary. Then humanity arrived, driven by the vision of a vibrant fishery in every body of water. Before the advent of aerial delivery, horses bore the aquatic cargo to these remote lakes. A skilled biologist, leading a pack train, would pause at a mountain stream, unfastening milk cans secured to the animal's flanks to meticulously replenish the water. The neck of each can was sealed with burlap, as a conventional lid could not prevent the water from unsettling during transit. Each rhythmic step of the horse created a gentle sloshing motion within the can, their rudimentary aeration system. A single journey through the rugged mountains could consume a week in one direction, permitting only a handful of lakes to be stocked at a time. The Uinta Mountains alone boast more than 650 such bodies of water. Utah's own Division of Wildlife Resources candidly acknowledges that no one documented the precise date or identity of the individual who first conceived of dispensing fish from an aircraft. The program's confirmed inception year is 1956. It was not a singular visionary hero, but rather a state that had simply reached the operational limits of its traditional methods. The challenge was unequivocally clear. Transporting fish via pack horse to every distant lake demanded weeks of summer travel, scores of personnel and animals, and outcomes heavily reliant on both the mountain trail's weather and the conditions at the lake itself. A single hatchery could not produce fish at a rate that pack horses could deliver them alive, and the state governed hundreds of lakes completely beyond road access. The airplane offered an immediate and definitive solution. A single flight could accomplish what days of horse travel once required. One pilot could complete in a morning what an entire pack train spent a week achieving. The implementation of this method was not without its initial variations. In 1965, 9 years after the inaugural plane flights, Utah's Division of Fish and Game explored an alternative: helicopters. Juvenile fish were placed in plastic bags, approximately 50 by 60 centimeters in dimension, filled with water and oxygen, much like a carefully prepared aquarium ready for transit. The helicopter would ferry these bags to the lake and simply empty their contents into the water. This experiment, like many such ventures, yielded predictable results. Helicopters proved more costly than airplanes and consumed significantly more fuel per volume of fish transported. The fixed-wing aircraft thus remained the primary method. Helicopters subsequently found their specialized role in areas where mountains are less imposing and flying conditions are simpler, as later adopted in New York's Adirondacks. By the late 1960s, aerial fish stocking in Utah had transitioned from an experimental endeavor to an ingrained practice. What began as an unrecorded pilot's attempt blossomed into an annual tradition that has persevered without interruption for 70 years. For 7 decades, this initiative was celebrated as a triumph of human ingenuity over geographical constraints. Remote lakes, once inaccessible, finally received fish. However, these lakes were not simply awaiting anglers. They were, in a deeper sense, awaiting a predator that had never before existed within their waters. The lakes where the first trout arrived offered no resistance whatsoever. There were no pike, no bass, no native aquatic hunters. For 5,000 years, the presence of fish had been a theoretical impossibility, an evolutionary pathway never taken. Now they descended from the sky, fully prepared to consume anything that moved. This ecological encounter was not with the more commonly known boreal toad. In these particular mountains, the introduced fish met an entirely distinct species, the boreal chorus frog. Measuring 7 to 8 centimeters in body length, adorned with dark spots on its belly and a distinctive white stripe along its back, this amphibian laid its eggs directly in the shallow waters of bogs and lakes. These were the very same waters where trout now arrived, possessing an insatiable appetite and facing absolutely no natural limitations. Today, the population of the boreal chorus frog across the southern Rocky Mountain region, which encompasses Utah, has dwindled to just 1% of its former breeding range. 1%. Trout are not the sole factor contributing to this decline. A chytrid fungus known for devastating amphibian skin has eliminated more frogs than any fish. This fungus, too, is non-native. It most likely originated on the Korean peninsula and disseminated globally along a similar trajectory to that of the trout. Through commerce, carried by humans transporting live animals to environments unprepared for their presence. The fungus infiltrates the frog's skin, which the animal uses for respiration almost as much as its lungs. As the skin deteriorates, the crucial salt balance in the blood becomes dangerously unstable, ultimately causing the heart to cease function. Yet, in areas untouched by the fungus, trout alone completed the task, voraciously consuming eggs and larvae before they could mature into organisms capable of self-preservation. The lakes once labeled as barren were never truly so. They were simply habitats for creatures incapable of outmaneuvering a predator that had not yet been introduced. This ecological reality, however, did not halt the program. The planes continued their flights, and they persist to this day. The conflict between trout and frogs is not the only ecological imbalance this program ignited. The golden trout, resplendent in its bright gold coloration with crimson spots, a species indigenous solely to the southern Sierra Nevada and California, became a highly coveted trophy fish for the Uinta Lakes as early as the 1920s. Utah diligently transported these fish for decades. By the 1950s, brook trout, another introduced species but significantly more aggressive, began to appear in the very same lakes. The golden trout proved unable to compete. One population after another diminished. Utah attempted to rectify this situation with new introductions of golden trout throughout the 1960s and the 1970s. The outcome was consistently the same. Brook trout invariably dominated. Today, golden trout persist in only 2 isolated stretches of the high Uintas. In 2012, following years without new stocking, the Division of Wildlife Resources negotiated an agreement with Wyoming's Fish Department for eggs and recommenced stocking a species the program itself had once nearly eradicated. It is the same aircraft, the same operational technology, the same 7-compartment tank. Only now, the objective is not to populate an empty lake, but to safeguard a dwindling species from complete disappearance. However, most people did not encounter this program through the plight of the golden trout or the struggles of the frogs. They discovered it through online video. In 2013, a pilot named Ted Hallos attached an affordable action camera to the underside of his aircraft, simply to capture the spectacle from an external perspective. The resulting video rapidly went viral across the internet, garnering millions of views and comments hailing it as the most extraordinary occupation imaginable. Yet, virtually no one watching the ethereal cascade of trout descending into mirror still waters pondered the ecological consequences for the lake once the camera ceased recording. The process itself appears deceptively straightforward. The aircraft glides over the forest, the hatch opens, and a column of water brimming with fish falls earthward. But beneath this apparent simplicity lies a meticulously calibrated system. The water is maintained at a precise cold temperature. The fish are deliberately unfed before the flight, and each of the tank's 7 compartments is designated for a specific lake. One flight can carry 35,000 juvenile fish, requiring no mid-air refueling, and service between 40 to 60 lakes in a single morning. Observers on the ground rarely discern the actual moment of release. The engine's roar typically masks all other sounds. Yet, those who have positioned themselves on a lakeshore precisely as the hatch opens consistently describe the same auditory phenomenon: the distinct sound of falling rain resonating across the water. Before these fish ever behold the open sky, they spend months maturing in hatchery pools, immersed in water kept a few degrees colder than the lake water. This precise temperature regulation ensures the young fish do not experience an abrupt thermal shock during transfer. Biologists meticulously weigh out batches down to the gram. An excessive number of fish in a single tank compartment would deplete the oxygen levels, even for a brief flight. The truck conveying the tanks departs for the airfield before sunrise, as warm daytime air in the cargo bed represents an additional source of stress that can only be mitigated by rapid transport. Every minute detail of that morning's operation serves one overarching purpose: to ensure that the fish, spending less than a minute airborne, arrive alive. The juvenile fish measure 3 to 5 centimeters in length, sufficiently small that air resistance significantly decelerates their descent. They do not forcefully impact the water. Rather, they gently plop in. An astounding 95% survive a fall from a height that would certainly prove fatal to a human being. The program receives not a single dollar from the state budget. Every cent is derived from the sales of fishing licenses. Anglers directly finance the very fish they will later endeavor to catch. Why does this cycle repeat annually, rather than being a one-time event? Utah's mountain lakes freeze almost entirely to their beds each winter. The ice creates an impenetrable seal over the water. Oxygen becomes scarce, and any fish that have not managed to descend into deeper pockets of water perish precisely where they are. A lake teeming with trout in August can be utterly barren by spring. This phenomenon is known as winter kill. Every spring thus necessitates a new flight, because the fish from the previous summer may simply no longer exist. The deepest of these lakes contain merely a few meters of water within their bedrock basins. In winter, ice can consume the majority of that depth, leaving the fish confined to a strip of water only a few dozen centimeters deep, where oxygen depletes far more rapidly than the sun can melt the surface come spring. Lakes situated on higher ridges freeze earlier and thaw later than those at lower elevations, and these are the ones that most frequently lose their fish. The same relentless cycle unfolds every year. The plane flies, the fish fall, the fish perish beneath the ice, and the following summer, the entire process commences anew. This program is not exclusive to Utah. At least 10 other states operate similar initiatives. The method first emerged in California in the mid-1940s when pilots returning from wartime service brought home expertise in low-altitude flying and a desire to utilize it in ways that would pose no threat to human lives. The lead pilot behind that initial program had once commanded a B-24 heavy bomber over the Pacific. Now he was deploying trout fingerlings instead of ordnance. In Alaska, Colorado, and Oregon, fish take to the skies for identical reasons: mountainous terrain, an absence of roads, and no alternative means of access. In New York, where the highest peak in the Adirondacks reaches only about 1,600 meters, a modest elevation by Western standards, the program employs helicopters rather than airplanes. During winter and spring, fish are transported to tributaries and ponds as yearlings, already mature enough to thrive immediately in the water. In the fall, when flying conditions permit fixed-wing aircraft to participate, the fingerlings delivered are slightly larger, intended to complete their growth in the wild. The majority of fish stocked in that region are a specially bred hybrid, adapted for the more acidic waters of the Adirondacks, as ordinary brook trout simply cannot endure there. The very same helicopters utilized in New York's stocking operations are sometimes those also used to transport the state's governor. The same fleet, the same skilled pilots, simply a different type of cargo. 10 states, the identical methodology, The same underlying rationale: waters that no road can reach. Elsewhere in the mountains, some lakes underwent a different kind of ecological experiment: the complete removal of fish. Employing electroshock equipment, nets, and occasionally chemical treatments, biologists meticulously cleared the waters of all swimming and feeding organisms. In lakes where trout were entirely eradicated, native amphibians began to recover within 2 to 5 years. After just a few seasons, a body of water that had not seen frog eggs in decades once again teemed with life. Animals that had patiently awaited their turn, lingering just beneath the surface, in neighboring bogs, or within the very memory of an ecosystem that had not forgotten how to thrive without a dominant predator. Biologists who have closely monitored these cases for years describe the phenomenon with a sense bordering on disbelief. A lake once considered permanently altered begins to croak with life again within a season or two of the fish being removed. Larvae that had been absent for decades reappeared within the initial warm months. This evidence points to one unequivocal conclusion: the ecological disruption caused by trout is not permanent. It reverses far more rapidly than anyone had anticipated. That is the single most critical finding from decades of research into aerial fish stocking. Not merely that fish cause harm, but that their removal almost invariably works. However, this hopeful outcome only holds where the fish are removed permanently and where the program continues its ongoing reintroductions, which it does across most of the mountain lakes of the American West. That delicate balance never truly arrives. A lake cannot simultaneously serve as a vital refuge for a disappearing native species and a yearly target for a fresh batch of introduced trout. Today, most of the fish released from plains are sterile, specifically bred to prevent them from reproducing in the wild. The trout are present, and anglers continue to catch them, but they do not propagate into new territories on their own. This represents a complex compromise between a program that will continue to operate as long as there is demand for fishing and an ecosystem no longer facing the uncontrolled spread of an invasive species. Does this truly resolve the problem? Not entirely. Sterile trout still consume frog eggs the very summer they are introduced. They still compete with zooplankton for food. They still inhabit the lake until they succumb beneath the ice. This approach is essentially the management of an ecological impact that has already occurred and continues to repeat each year, because terminating the program would sever hundreds of thousands of anglers from the very lakes around which an entire mountain summer culture is constructed. Ted Hallos does not purport to resolve this fundamental contradiction. He simply continues his flights. Every summer he coordinates aerial stocking operations across Utah, from the Uintas to the La Salles. Each summer, the aircraft ascends, and fish descend, like a rain that no one explicitly ordered, yet everyone implicitly anticipates. This year, 11.6 million fish were released into Utah's lakes and reservoirs, a slight decrease from last year's 12.8 million. This adjustment anticipates the state's population potentially doubling by 2050, while the number of hatcheries and the available water resources will not expand proportionally. The Division of Wildlife Resources has recently unveiled a 30-year strategic plan, detailing how to allocate fish that will inevitably prove insufficient for every individual who wishes to cast a line. A component of that plan is already underway. In the town of Loa, a new hatchery is being constructed, replacing one that ceased operations in 2014 after an invasive snail was introduced, most likely transported on someone's recreational gear or within a home aquarium. The new facility is engineered to produce twice the volume of fish as its predecessor, sustained by the same cold springs that nourished the original hatchery for decades. Fishing generates more than $1 billion annually for Utah and sustains 8,000 jobs. That formidable economic scale represents the formidable challenge any decision regarding native frog populations must contend with. For the first time, that same comprehensive plan includes a specific budget allocation for the western chorus frog. The very state that spent 70 years introducing trout into waters where these frogs lived, is now commencing the cultivation of those same frogs in those same hatcheries, aiming to prevent their inclusion on the endangered species list. No one is contemplating an end to aerial fish stocking in Utah. Too many anglers, too much revenue hangs in the balance. But for the first time in 7 decades, the very machinery that instigated the ecological disruption has also begun to work in the opposing direction. A rain of trout over mirror-still water, a captivating video for social media, and a frog that is no longer present might finally be given the opportunity to understand why, and whether it too might yet return. If you found this exploration of ecological balance and human impact compelling, consider subscribing to our channel for more in-depth stories.